In this video, I'm going to make one more example of matrix multiplication, and I'm going to multiply 5 by 4 matrix to a 4 by 3 matrix. So let's suppose we have, and I already covered multiplication other times, but this is going to be one more example, as I said, because the more you have, the better. So let's suppose we have 1, 2, 3, 4, I don't know, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Because I lack of imagination. This is gonna be our matrix A, and since I really lack of imagination, I'm gonna make my matrix B the same. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, but I'm gonna stop here. So we basically have A, which is a 5 by 4 matrix, and B, which is a 4 by 3 matrix. I remember the reason why it's 5 by 4 is that we have 1, 2, 3, 4, 5 by 1, 2, 3, 4. And then we have 4 by 3 matrix, so 1, 2, 3, 4 by 3, so 1, 2, 3. And we can actually multiply them together. So if we're going to find C, which is A times B, this matrix is gonna be, well, a hell of a matrix. 1 times 1, because we're basically going to do 1 times 1 plus 2 times 4 plus 3 times 7 plus 4 times 10. And we're going to do the same for the others. So 1 times 1 plus 2 times 4 plus 3 times 7 plus 4 times 10. And then here we're basically going to have 1 times 2 plus 2 times 5 plus 3 times 8, 3 times 8 plus 4 times 11. And then we're going to have 1 times 3 plus 2 times 6 plus 3 times 9 plus 4 times 12. And then we have 5 times 1 plus 6 times 5 plus 7 times 8 8 times 11. Then we're going to have 5 times 2 plus 6 times 5 plus 7 times 8 oh no, I'm sorry, what did I do? 5 times 1, 6.4, 7 times 7, and I'm sorry, 8 times 10. And yeah, because I was with the very first one. So 5 times 2 plus 6 times 5, 7 times 8, and then 8 times 11. And then we have 5 times 3 plus 6 times 6, 7 times 9 plus 8 times 12. We're gonna have 9 times 1 and 9 times 1 plus 10 times 4 plus 11 times 7 plus 12 times 10. And then we have 9 times 2 9 times 2 plus 10 times 5 plus 11 times 8 plus 12 times 11. Then we have 9 times 3 plus 10 times 6, 11 times 9, 12 times 12. And now we have 13 times 1 plus 14 times 4 plus 15 times 7, 16 times 10. 13 times 2, 14 times 5, 15 times 8, 16 times 11, 13 times 3 plus 14 times 6 plus 15 times 9 plus 16 times 12. You should have got it by now. So again, 17 times 1 is 18 times 4 and so on. So 17 plus 1 is 18 times 4 plus 19 times 7 plus 20 times 10. And then we have 17 times 2 is 18 times 5 plus 19 times 8 plus 20 times 11 plus 17 times 3 plus 18 times 6 plus 19 times 9 plus 20 times 12. Okay, and so this is our matrix which I'm gonna compute. So what do we have here? 1 plus 8 plus 21 plus 40, 2 plus 10 plus 24 plus 44, and then we have 3 plus 12 plus 27 plus 48, and we have 5 plus 24 plus 49 plus 80, 10 plus 30 plus 56 plus 88, 15 plus 36 plus 63 plus 96, 9 plus 40 plus 77 plus 120, 18 plus 50 plus 88 plus 132. And then we have 27 plus 60 plus 99 plus 144. Then we have 13 plus 56 plus 105, 160. 26 plus 70 plus 120 plus 176. 39 plus 84 plus 135 plus 192. 17 plus 72 plus 133 plus 200. 34 plus 90 plus 152 plus 220, and 51, 108, 171 plus 240. So this is our matrix. We have still to compute, so those are just addition, silly addition. So this is gonna give us our final matrix at last. which is gonna be 70, 80, 90, 158, 184, 210, 246, 288, 330, 334, 392, 450, 422, 496, and 570. So this is our final metrics. Yeah, I should have chose a better metrics with lower numbers, but anyway, because there were big products and then additions within all those big products, and computing this was a little bit tedious because of the high numbers, but I invented it, I chose it myself, so I can't blame myself for choosing it. Anyway, the main concept here, once again, is how you do the multiplication. Now I've done all those, so you should be familiar with it by now. So as again, as you can basically see, basically multiply for each and every one, and then you go down, you go down, you go down. So as I said, you gotta pay attention about what you're doing with matrix multiplication. You also have to make sure that the matrices are compatible, because you can't now actually always multiply two matrices.